Hi, this is Henry with Show My Hobby, and I am also a member of the Metrolina Model Railroaders Club. And a little over a week ago, this question came in. I have removed the user's name, email address, and contact information. Basically, they have a 4x8 oval that they have created, um, and they have a passing lane. And they wish to have a siding where they want to be able to place one locomotive and turn the power off on that siding while at the same time continuing to run trains on their main line. Now, I do have other questions that I wish to ask this gentleman. I've started to answer his question, but time has been limited and it's taken me quite some time to do so. And I put a lot of information in here. Um, and he can certainly read this. However, today, about 5 or 6 days after he sent his question, um, I'm just now able to get back to him, and I let him know that it may take me a couple more days. And he says he already solved the problem. However, the way in which he words his particular question brings up to me the fact that he probably has very little knowledge about how to wire a train layout, especially for multiple trains or to use blocking um, or power districts. So I'm 6 pages into this already, and I was going to put together a diagram for him. And I came up with a diagram, and basically, this video is, not only to help him out, but to help out many, many others. One can surely obtain most of this information simply by reading up on the electronics of a model railroad. But that will take a little bit of time, and this right now has become fairly common knowledge, I think, mostly because in order to wire a layout these days, um, it's become much, much easier if you plan to use DCC operation and you want a nice basic layout. He mentions he has a 4x8 layout. Well, I'm using AnyRail software right here, and I've made an entire layout for him. Okay, now he just talked about one siding, and it looks like a passing siding, um, is what I tended to understand. Um, and when you're using track, of course, I asked him in this question, you know, whose tracks are you using, um, and a couple other questions. Why is that important? Well, if you're talking about O scale, um, and you're using 3 rail, then there's a certain way to go about it. But if you're using 2 rail, which the majority of people are, it can be a little bit easier to accomplish this. But also comes down to how did you make the passing siding? If you're using Atlas standard track, um, there are a few caveats there because the sidings can be made easily just using standard snap switches. However, if you want a smaller track siding, you have to use um, some additional track that do not come in the track pack, um, as well as your extra circle and so on and so forth. So basically, he just talked about one siding, and I didn't get a response from him before I started creating my answer to him, because I haven't sent him my response yet, and that's understandable. But basically, I wanted to show very quickly what possible sidings he could be talking about. So I think that basically he's talking about this type of siding right here, passing siding right here. Okay, where basically he just has one outer main loop, and then he has, you know, an inside track thing for like a station. So there might be a train station sitting right about here. Okay, and he just wants to go and maybe drop one train off right here while this train or another train continues on the outer loop. So if you look in at some Atlas track layout plans, or how to create an Atlas siding, this right here is an Atlas siding using SnapTrack. So if you purchase like an Atlas number 4 snap switch, which is like 850 or 851, I believe on the back of it are instructions on how to create this particular passing siding. Now, why am I talking about this particular passing siding? Well, this is a passing siding where 18-inch radius curves were used right here. You don't necessarily have to have a straight track there, but you would have a half quarter circle, and then you want, and this could be another full quarter circle. And you may not have an oval, you might have a full circle, but once you introduce the turnouts, you would have at least some sort of an oval. So instead of having mini track here, you might just have one. Well, as mentioned, the gentleman said he had a 4x8 layout. This is 4 feet in this direction and 8 feet in this direction. So I just drew a regular layout board for a 4x8 and maximize the amount of track I could get on an oval using Atlas standard track. Okay, so this 152 here represents the track number. That should be the track number for standard 18-inch radius curve by Atlas, code 100 track. Anyway, so that's what we have here. Now, if you get the pack of SnapTrack number 4, it has an 850 and an 851 turnout in it. If you get a dual pack, or you can just get one left hand and one right hand. This right here is the left hand, this is the right hand. This is 851, this is number 850. It comes with an 835, which is a 1/3 18-inch radius curve. So by adding 2 more curves plus 2 more curves, total of 4 curves, and what comes in that track pack, you can create an exact bypass track. Okay, if you have a straight here, you need a straight here. Okay, so imagine that's what you have. So I'm going to turn some of this stuff off, come back, and then show you the basic outline. So basically, this right here is a curve. Here are the 850 and the 851 turnouts, and then we turn on our first passing siding. That right there is it. Okay, and so his question was, how do you wire the layout so that you can park a train in this siding, turn its power off while still controlling the train that's on the outside main loop? If you have only one transformer, that's a DC transformer, then his question was, what would he need to turn off this track? Okay, so the way he mentions it is, he says, finally putting together a simple oval 4x8 layout with 2 turnouts connecting bracketing a couple of 9-inch straights. Question is, I assume that with the proper power pack, I can connect the spade connectors to the same power pack that runs the track itself. Also, I assume that if I want to turn off the turnout track, leave the train sitting at the station, while the larger oval continues to run another train, I would need some kind of buffer to turn on and off. Hope this makes sense. Thanks for your attention. Alright, so as mentioned, I suspect this is what he's talking about. Okay, this is pretty much what his layout might look like. Okay, I am using a trial piece of software here to record this, and apparently I'm already 10 minutes into it because it is limited to 10 minutes. So maybe I can stitch these videos together when I'm done. Um, I'm not sure, so I'm restarting. Um, so every 10 minutes here, this is going to stop. We'll see how I have to put it back together later. At any rate, as I was mentioning, I believe this is the kind of situation he was talking about. One transformer, probably DC, and how do we turn this off? Well, in my response to him, you know, not meaning to be mean, but basically when he says he needs some sort of buffer to turn on and off, basically that's telling me he hasn't done a whole lot of reading on the nomenclature about model railroads. Okay, so number one, that is a siding. And what he would need is, yes, some sort of buffer or basically some sort of switch to turn the power on and off of this track. Well, Atlas provides connectors and selectors, okay, to do that. A connector has some single pole, single throw switches on it, one of them. And I'm going to pretty much show you what that looks like here. Okay, so there's an Atlas connector. This is what it looks like. It's item number 0205 on Atlas's website. Right here on the left hand side or the right hand side, power can be connected, and assuming you're using one transformer, which wouldn't matter, you would only use one transformer, you would mostly come in from the left hand side or the right hand side on these two terminals right here, and then power is shared across these three switches. This particular terminal here connects power, and let's flip to the diagram, and you can see that in the position that this thing is currently sitting in now, this bottom left hand terminal corresponds with the top right hand terminal in the first switch, okay, and this terminal, the top left hand side terminal, corresponds to the top left hand terminal of switch number 1. Okay, this is the diagram on the back of the Atlas connector, and you can see that it can turn, they actually switch both of these switches at the same time. So if you slide switch in position 1 upward, it will turn on power, or whatever power is flowing through these two terminals, it will route them through these terminals at the top onto your track. Now, notice that even though it does have two terminals, Atlas is only showing one particular lead going to the connector, which in many cases for track powering, that's all you need. Most of the time, you may get to a situation where you have a loop or a turntable where you might be running power through both terminals, but for the most part, you'll just need one. Okay? So here it talks about, a common rail system and an insulated gap system, which in that big long drawn out letter I talk about, I first give him definitions for what these things mean, what they are, and how you use them, and so on and so forth. Okay, I will most likely try to present most of this with this video. At first I'll be sending it to him, but I'll probably end up posting it on my website and then putting the videos together, and everything will be on the website. But at any rate, this is being suggested for common rail system. But you can see that the same controller can also be used to wire accessories. Okay, and here with accessories, they're showing that both leads are being used directly to each individual accessory. However, there is a concept of using a light bus or accessories bus, just like you would the rail system, or a rail bus, a rail power bus, so that all the common leads connect to just one standard bus line, and you just drop one feeder from each individual house. Okay, but it can be done both ways. Doesn't really matter. Here for the track, I am suggesting a common rail system. So we're only going to be connecting one terminal from a transformer through the connector, or we can use a selector. The difference between using a connector and a selector is that the selector already just has one lead, and it's better designed for the use with two transformers or two caps. So that one common, well, common is not the right word to tell you right here. Okay, so here's a diagram of how you would use this one. Okay, here's a power cab A, and here's a power cab B. You're taking one line or one lead from the first transformer, and you're putting it into the first top leftmost connector on the selector, and then you're taking power lead from the second transformer and plugging it there. The common rail, or the rail that they have in common, the power lead that they have in common, is connected together, and then it goes directly to the track. And Atlas suggests that your common rail be the inside rail, and that your gapped rail be the outside rail. It could easily be reversed, but in pretty much all of their diagrams, they have pretty much standardized it so that the outside track is the gapped rail, meaning it is the rail you will put the insulators on. It is the rail that you will cut a hole or slice a track if you're not using actual insulators. You just need a gap in there. It doesn't really, no electrical connection on that rail. So you break that connection however you need to do it. Easiest way is to use insulated plastic rail joiners while you're building the layout. But let's say you already put the layout together all the way completely. There's no worries. Just take a Dremel or a hacksaw or something and slice open the rail. And however you cut it is typically enough distance to create a gap electrically between the rail. And then that's all you need. Now, I said it's all you need, but at the same point in time, between a gap from here to here, you do need to drop a feeder wire. You need to drop a line from here to there. So very quickly, in this guy's scenario, imagine we have the oval right here, okay? And then let's say this section right here is on the inside, okay? And it happens to be his passing siding. So the passing siding, we need to drop at least one rail in its outside corresponding rail, and then feed it to block number 1 or block number 2. Most people will start with their main line being, the first blocks, and then their spurs and sidings will take on additional blocks. Okay, that's pretty much what I've done here. Now this right here, this is not the diagram that shows up on the back of the selector switch. This is one I found online. Somebody else had already created it. Okay. Alright, I got about 20 seconds before it flips before this recording ends. So I'm going to go ahead and let it in, and I'll continue. Okay, so in this particular diagram, my outside is my gap rail, my outside rail is my gap rail, my inside rail is the common rail. Okay, so I've created a common bus, power bus. This would typically be underneath the layout. Okay, just one loop of wire goes all the way around the bottom of the layout. The easiest way to, create that common rail system. Have your wire, run it through some eye screws, drop them every so often, and feed your wire through it. Might hang a quarter of an inch to an inch down below the track, but there you have it. Now, get you some feeder wires. Atlas makes them, a lot of other companies make them, but the way Atlas makes them is they just solder a strip of wire to a rail joiner, a metal rail joiner, okay? And then that's it. And if you don't get them, store bought, you can make them yourself. You've got your metal rail joiners, just solder a piece of wire to it and you're ready to go. And then drop these every so many feet. Now, in a 4x8 layout, for the most part, you could say that you really don't need more than one set of connections to the tracks. Okay? Now, my HO scale layout is an L-shaped 4x8 with a lip that is 3x4 when it hangs down through here. Okay? Let's see if it's easily accessible here or if I've been working on too many things. Yeah, I can show that to you real quick. Save. Alright, that's my layout. Okay, and I can tell you that my layout required dropping more than one feeder. So some people say maybe every 3 or 4 tracks drop a feeder. Okay, but that's totally up to you. However, you do need to have at least a feeder in every block. So in the example that I've been showing you here, the different colors are the different sections. Okay, even though this gentleman only wanted to create one little section or one little bypass siding, the reason I'm showing you several in this particular layout comes down to what tracks did he use in order to create the siding. If he created the siding like this in a scenario where he used 18-inch radius curves, he used snap track, he used the stuff that came in the snap track, then that means he can buy 4 more 18-inch radius curves and he can make a siding with just those extra curve tracks. However, if his intent is to span an area larger than one track space, it's going to require him to use a 1¼ inch small straight in order to get the tracks to actually come together. Now, I think Atlas suggests you need a 1½ inch straight. This right here is AnyRail, as I mentioned one time before, and AnyRail, has done a very good job of putting tracks together in such a way that it suggests exactly which size smaller piece I need. In this particular case, 1, 2, 3, 4, I'm also using 4 straight tracks for this inner loop. As you can see right there, that's the loop, and I've made a siding track right here. This could very well just have come out to here. Now, had it come out to here, it's possible that I might need a 1½ inch, or I might need a different smaller piece of track. Regardless, the point that I'm trying to show here is that if you expand the distance between the curves sections, you're going to need something other than a standard piece of track in order to fit the gap that occurs from side to side, or it can be up to down. It doesn't matter. It just, that distance, the more track you lay in here, the difference comes in the small piece that you'll need to fit between the tracks. In this particular layout, this is a 1 1/4 inch track piece. On the back of the Atlas thing, I think it says 1 1/2 or 1 3/4, but it doesn't tell us what the distance is between the curves. Just know that you'll need something different. And you can cut this piece out of another straight if you don't have the smaller Atlas pieces, or you can use flex track and cut it as well. Down here, we will need flex. Okay, so down here, this right here, in order to make this particular passing siding, you need not only what comes in the track pack, which is 1/835 with the turnout. You'll need a second set of 835 tracks, which are 1 1/3 18-inch radius curves, and then you need some straights. Here I've got 2 straights. I've got one straight that is a feeder track, okay, and the other straight is a piece of flex track that was cut. And this thing tells me exactly how long it is. It's 8 inches and 7/8 inches long, which is not quite the length of a 9-inch straight. So this one would need to be trimmed down, and a flex piece of track is 36 inches, so it would need to be trimmed down a lot if a full piece of flex was used. Okay, so the reason I have 3 loops in here, whereas the gentleman only requested or only stated that he had 1, was to show you that you would need different types of track in order to create your passing siding. Okay, now the second part of this is to illustrate how you use the connector or the selector switch. Okay, so if you've got one transformer, and that transformer can be a regular DC transformer, or it can be a DCC transformer. Now in DCC, to actually accomplish what he wanted to accomplish, you do not have to use a common rail system or a gapped rail system at all. You just wire directly from a command station the 2 terminals directly to the tracks, and that's it, so long as you're using pretty much DCC based trains. And if you have a particular DCC command station like a Bachmann or a Digitrax, you can still run one DC locomotive as well as the rest of them being DCC locomotives, okay, with either of those 2 command stations or DCC systems. With everybody else's, you will have to be running all DCC enabled locomotives. Okay, but basically in that particular case, what's going on is you can stop one train and run another train anywhere you want to without having to turn the power off. But if you, wherever that train is located. In this particular case, if we're using a regular DC transformer, we can stick the train here, and then in the blocking system that I'm about to show you, we will be able to turn off the power in this track, in this section, and then continue using the one transformer to run another train around the layout. Okay, so again, I'm at 9 minutes and 16 seconds in this segment of this video, so I'm gonna let it play out here for a moment. Again, we have connectors up here, we have selectors down here. You would not use this in both cases. I'm gonna turn off the selectors for now. Okay, and then let me go ahead and show my power block lines. I'll explain those when the next segment starts. Okay, but we have one transformer, and for this particular layout, it takes a total of 8 blocks, 3 blocks per connector, Okay, so we have our one transformer, and this particular layout takes 8 blocks. 3 blocks per connector, and the first 2 are filled, the third one is not. Also, for the connectors in the diagram are turned upward, so that up is in the on position. However, in mine, I simply put the connectors in there upside down. So pay no attention to the words. Basically, the up position is off here and the on position is down. And transformer A being connected, I've got it connected coming in here on the left hand side. Cab A is connecting here, which means the first terminal on the left at the bottom would feed into my blocking system. Okay? Alright. So we'll get that out of the way. So that's the way this is set up. So block 1 is right here. Okay? So imagine we're building this system, we're building this layout, and I'm starting in a clockwise direction, up top, block number 1. Now, do you need to block out everything like this? No, you don't. You could have blocked it out different ways, but in my particular case, I'm blocking them out to maximize all the different places I could stop a train and let it set with just one transformer, and then use or run other trains. So I could actually have 5 or 6 different trains on this layout. All of them can be in different blocks, and at one at a time I can control whichever train is in what block. Okay, so the first section is here. This is where the gaps go. Okay, this little triangular looking connector piece is going to be on the outside rail. So right there, that would be a plastic coupler right there. This one would have a plastic coupler outside rail, even though it's going into the inside curve. Block number 2 is over here. So this outside rail would have the plastic insulator on it right here, the plastic rail joiner. Okay, come in, and this right here is my second block. This is my third block right here. It's a straight section. My fourth block just controls these 2 turnouts. Okay. Block number 5 would complete my mainline loop, with my mainline being the outermost loop. Okay. So now, even without having the passing siding, I would have 5 blocks right now. Okay. And using a connector, one transformer, I would have these all set. I'm using my top lead here as my plus lead. It would come up top at the top left hand corner. This first terminal lead right here, this is the line that's coming out of it, and it would come down and, or however route itself from here and be wired directly to the outside rail in this area. All the inside rail feeders are going to go here, and I've dropped one in every particular section. Now, it's not really popular for a lot of people to use the 840 terminal track because it physically shows wires being exposed at the top of the layout just beside the track, and they have screw terminals on them. Now, you wouldn't necessarily use track feeders if that were the case, but I just put that track in there because that's one way to do it. It's a simple and easy way. All you need is wires. You don't need to solder anything. You don't need to buy the track feeders. You don't have to make the track feeders. You would just drill holes in your bench work right behind the terminal block there, and run your wire, screw it in there, And now if you've got your bus wire, the inside rail, I dropped a feeder for the common rail. It won't go all the way back to the transformer. It's just going to go down to my bus wire, which is running underneath the track. And the easiest way to connect one of these is use a T-connector. It's a T-clamp. All you do is you take the wires, you don't even have to strip it. You don't have to strip either one. You don't have to strip the wire on the bus, and you don't have to strip the wire that you just dropped from the feeder. You just plug it into the T-connector, and you use a crimper, and you crimp it. Okay? You squeeze it together, and it'll make a connection, and it looks nice and neat, and everything's cool. Okay? And usually that'll last a good long time. Once you've made a good solid connection, it's nice and strong, the wire and the power will flow seamlessly. If you're using a track feeder wire with a rail joiner, instead of being connected halfway in the middle of this track, you just go to the nearest connection between tracks, and your feeder wires would have the rail joiners on the end. It would be one. And notice I'm using red and black here. Okay, so typically if you buy the Atlas track feeders, they're always black, always. Okay, so here you drop the black feeder, drop it, and then connect it to your bus wire underneath, and that's it. Now notice the bus wire does connect to a line that goes to what I'm saying is the negative side of the transformer. Okay, it's just the other lead of the transformer. The positive lead, or the other lead of the transformer, goes into the one side of the connectors. Now this particular line right here is not necessarily necessary. Okay, you don't need it. I just wired it in there just so you can see that if you want to put both terminals in there, you can, but it's not connected to anything coming out. Okay, nothing is coming out of the connectors that correspond to that wire. Okay, so it's not really necessary. Now, if you wish to use two transformers, whether, let's say it's going to be a DC transformer. In the case of a DCC transformer, you most likely won't need more than one transformer. In a very large layout, you might use a power booster or something like that, but you won't need one. You won't need another command station per se. Okay, and then your blocking is just totally up to you if you choose to do that. But in DC only systems, if you want to run more than one locomotive at a time, you need another transformer. Okay, so let's add that second transformer. In that particular case, you can't use, or you won't be able to use connectors in this particular manner. Okay, because you can't connect transformer B to a connector at the same time transformer A is, not on this side. Okay, now there's a part I don't discuss here where there's another way to use this, and that's a bit more advanced, so I'm not going to mention it. But right now for this thing, this doesn't work. So at this point in time, we get rid of the connectors and we use the selectors only. The selectors are designed for two transformers. Okay, so we get one, the positive rail, going into both inputs into the selector. And remember what the selector switch looks like. Looks like this. So it doesn't matter which side you come in from, but your input is here from cab A and here for cab B. It's just one common, it's just one power lead, usually the positive power lead. Okay, and then the output is this right here. These are the powered, typically plus block signals. These go and connect to the gapped rail. All right, so get that out of the way. All right, so now that we have that, we have two transformers. Both of these are DC. We've got the power plus going into the top and then to the bottom, and then we have everything else connected just like we had it connected before to the connectors, except for now they're connected to selectors. And there are four of these switches on each one of the selector. So Okay, so as I was saying, we only need 2 selectors in order to fulfill the 8 blocks that this particular layout has. Okay, so all of them, all the power leads have been routed to the different track locations. Now let's put in sidings. Put it in the first siding. The first siding turns out to be block number 6 for us. Okay, so all these other blocks have already been wired. Okay, so now block number 6 is going to be the second switch on the second selector. We want to wire down to it, over to the outside rail, the thing that corresponds to the outside rail. If you're not sure which one it is, go look on your outside main, and following it as it goes through the turnout, this right here is the switch. So this outside rail connection, that's where we put the feeder. This common rail section, which is on the inside, from here we drop a feeder track and it goes down to our bus wire. Okay, and now this guy's ready to go. Now with that in place, we can now use either of these transformers and operate this thing exactly like the guy asked. Okay, basically he can pull his first train, run it around, bring it into this section, and sit it there. Use a transformer A. He can either leave this selector in the A position, go into transformer A, or he can put it in the middle. Middle is off. If he put and his request was, how can he turn it off? So that would turn it off. Okay, so let's say he had a dual mode DCC locomotive, which makes a lot of sound even when it's just idling. Okay, so he could pull it in here and pull the switch to off. The train would sit there and would no longer have power going to the track. It would shut up when he moves this to the middle position. Okay, now if he just turns the transformer off, it would probably shut up. Well, it will, but no power going to the track, it'll shut up. In DC mode, if you're running a DCC locomotive, it requires power to make some noise. So one thing that you'll normally notice if you're unaware is that if you're running a dual mode locomotive in DC mode, when you first turn the throttle on, that's when it'll start going through maybe a startup sequence. It'll start idling, doing whatever it needs to do, but you will have to turn the throttle up probably past 25% before the locomotive will move. The first thing that will happen is its sound effects will come on, and then as you add more power to it, it'll get to a point where it can actually move the locomotive. Its starting point will be much higher than it would be on the throttle than if you were using a DCC system. A DCC system always has power on the rails, and when you turn the throttle, you're simply sending a command that the decoder receives that moves the locomotive. So on a DCC system, even when a locomotive is sitting idle, it's receiving power. So there's usually a function that will turn the sound off on a locomotive in DCC mode, but it very may well start up and go through its startup sequence the moment you power up the command station. Okay, so that's the difference there. So if you wanted to turn the power off with a DC transformer, you could either throttle it all the way down to 0 or move the switch to the middle position. Right now, he would be using transformer A. While that train is sitting there, he can now put a locomotive on the rest of the main line, make sure his turnouts are switched to go straight through in the normal position, and he can run the train using transformer B. Now, in order to do that in this particular layout scenario, he would then need to take blocks 1 through 5 and turn them all down to B. So the first full selector, he would turn all of those down, and then block number 5 down to B. And now all of these blocks would be controlled by transformer B. Okay? And he could run another train. The train in this particular block is idle, and it's sitting on either off, or if it's still on A, then it's being controlled by transformer A. But now, with this particular scenario, we could have another passing siding. Okay, so in this particular case, we have an inner loop here. We come through here and we have a passing siding right there. Okay, now with that particular passing siding going, he could continue to have another train here. Let's say what he wants to do is he's running this train right here on the outside loop. This one is sitting in this particular area, and let's say it's taking up all of this trackage right here, every bit of it. Okay, and this train out here is running in this particular direction. Let's say he wants to back it up. So now he needs to turn on this particular block, which is block number 7. So he come down here to block number 7, pull it down to the B position, stop his train, put it in reverse, and now turn his turnout and switch it and back it in here. Okay, and let's say it's a longer train and it takes up the majority of this area right here. So he backs it into here, the entire full train, and he stops it, switches his turnout back to the normal positions, to the open position, and then he wants to pull this train back out on the main and let it resume operating. So all he would do is, this train is sitting in block number 7. He can leave selector switch 7 on in the B position if he wants. He would then move tracks number 1 through 5 again all the way up. You would make sure he's got 6 in the up position, because that's the track that it's currently on. So all of these would all be in the A position. He'd move 1 through 6 in the A position. He'd turn the power back on, open up this particular turnout, and then out he would go. So right now he would have a train in this position just sitting there, and then he'll pull this train out and he can resume moving it around. After the train clears the turnout, flip it back to the open position, the closed position, normal position, and then just keep going around. Train sitting in here idle. Now we add in the third passing siding, and at any point in time, one cool thing to do here is, let's say it's a passenger car. He needs to stop and pick up some passengers. Okay, now right now this is a short siding. Okay, so you can't get a full passenger train in there. You might get a locomotive and an observation car. Okay, but let's assume that's it. We got a little small passenger station sitting right there, and that's what he's got on this little train that we pulled out there. Okay, so now he pulls this train in, turns it on. He would need to open up block number 8. Okay, put it in the up position. Okay, so this little small passenger car train comes through here. He's turning this turnout on. He pulls it in here. He stops it, closes this turnout. Okay, and now this train that he wanted to run on the outside loop, while this one is in the station accepting passengers, he goes back. It's already got 7 in the B position. He's going to flip 1 through 5 again, all down to B. The only thing in the A position right now is going to be block number 8 for this guy. This is just sitting there. He brings this guy out. Everything's moving strong. He's on the main line going around with blocks 1 through 5 plus block number 7. As soon as he clears block number 7, pulling it out, he'll move that probably back to the middle position, turn that track off, close his turnout, and again he's still running around on the outside block while his little passenger locomotive is here. Let's say this is a large freight train that he's got in here. So this freight train is running around on the outside track with no problem, doing this thing. He's sitting right here inside waiting for passengers to load. The passengers get loaded. Now he comes out, and 3 seconds. Okay, so resuming, and this should be the last segment here. Right now, we have a small passenger train sitting on this track being controlled by transformer A. On this track, running around on the outside main line, is a larger freight train, and it's doing its thing. Okay, now here is where model railroading gets fun, even being on a DC layout, and that is this. You got two trains, two transformers. They're operating at decent speed. You let this train go by, and you let it get at least one, maybe two blocks ahead. Okay, so let's say the large freight train gets over here. You're running it at a moderate speed. The transformer B is set to a moderate rate. That locomotive is running. This guy is down here. He's in the standalone position. But you're going to start him up. Transformer A is set. Block number 4 has been in position B. You're going to flip it all the way up to position A. Just that one. Turn on the power. Open up the turnout. Let this train come on out. Okay? Now, move it slowly and let this train run until this train gets to block number 2. When this train gets to block number 2, you should be entering block number 5 over here. So you take the 5 switch, move it into the A position real quick. It'll be in B, but you'll move it all the way up to A. You do it in advance of the train getting there. There's no train in that block. That train's sitting over here in block 2. It's not sitting, but it's moving slowly enough over here. You have this one locomotive. You've pulled it out. It was in block 4. It's about to go into block 5. You switch it up block 5 to position A. It goes here. You set the train to a good moderate level, a speed that matches pretty much the same speed as this one, so that neither of these trains catches or runs into the back of either end, and that neither of them gets to a block at the same time. So long as the blocks are spaced, in such a way that the distance between the trains can be maintained. As long as that can happen, as this locomotive gets ready to go from block 2 to block 3, you make sure the block 3 is still in position B. Meanwhile, this train should be approaching block A, so you flip, block number 1, you flip block number 1 up to position A. The train moves into it, goes through it, no problem. You're going into 3. 3 becomes 4. 4 goes down to B. You get prepared. This right here is going to make it to block number 2. Meanwhile, transformer B gets flipped to switch for number 5, gets switched down to B. And if you do that consistently with the right track plan on a DC layout using blocks, you can effectively run 2 locomotives powered by 2 different transformers around the whole main line. Okay? They'll be a block apart, which is why you see the blocking is spaced out the way it is in this particular layout. You would have no trouble running 2 trains effectively, and you can get very creative by turning turnouts at the same point in time, whereas you have one train that'll go on the outside, have another train that'll go on the inside. Now, this train layout is too small to have those trains running in opposite directions without crashing into each other in this area right here. Okay, so you can run them in the same direction behind each other, but you wouldn't be able to run them in opposite directions because there's too much distance right here for them to meet head to head. And that is exactly what they would do if you tried it with one train in one direction and the other train in the opposite direction. But 2 trains in the same direction, you can easily navigate whether it's going, clockwise or counterclockwise. Both trains on the same mainline actively by just moving the switches on the selector switch. Okay, moving into the block just ahead of the train getting there for the appropriate transformer. Okay, and like I said, that's when it really gets fun. I mean, it's fun doing it the other way, but it gets challenging to do it this way. You get it this way, it becomes a challenge, but very, very doable. Um, let's see if the desk train is here. That's okay. Let me make sure I save that. All right, so I'm at my desk right now, and I don't have the webcam to where you can see it, but this right here is my desk train layout. It's a layout that is built into a desk. This desk is for in scale, okay? And this is the layout pattern here. There are a lot of there's two double main lines right here. There's a line that moves up to the top and the back and goes down underneath. And my subway station is here. There's a subway underneath with a double crossover in it, okay, that gets me into this area back here. There's 3 layers or 3 levels on this particular layout. The top part has a passing siding right here. This passing siding has right on top of it is my actual train station. So the train station is up on the top level, and down underneath the train station is a double crossover inside the subway area. All of this is here. When I first built this layout, I built it using Atlas Selector switches, a combination of 4 transformers, okay, with nothing but selector switches, and basically I use 2 transformers to control trackage for my main lines, top level and bottom level, and the middle level. And then for my spurs, my sidings, this is where, train maintenance is and stuff like that. Over here is an industry, several industries, coal and sand right in here, a brewery back in here, and this is where inside this section right here I control this with the other 2 transformers to deal with my sidings. So I can have 2 trains running all the time, and they can be in opposite directions on the main lines, whether it's on the bottom or the top, or transversing from top to bottom as it goes around. Inside main and outside main. Those can be run by the 2 outside transformers. The 2 inside transformers can use to move freight and stuff back and forth and prepare trains all on the inside. So using selector switches are really, really nice. And it provides a lot of creativity that you can explore. The HO scale train layout that I have, let's get to it, Libraryville. Okay, this one too. I have it so that there are some blocks here. So the T's are, represent my turnouts. The B's are the blocks. Okay, so that in-scale layout that I showed you, I believe it has 26 blocks on it. This particular layout has about 26 blocks as well, somewhere between 24 and 26 if I remember correctly. I don't see that all of them are labeled. I have a track right here that I'm using as a as a programming track, and it's number 20 is the block that it's in. So maybe all the blocks are listed here. Let's see. It's been a while since I looked at this. This is 20. This is 20 blocks, not quite 26, not quite as many as the other. Now, the selector switches I have not put in place, so I've not set up my blocking here. It is in the diagram, but I've learned that you got to be able to play with something as you're building it. Don't start out with such a large scenario that you can't finish it, and this video is going to stop. Okay, so we've completed answering the question for how to use connectors and selectors, and I've answered the gentleman's question. But I'm going to throw this in a little bit. This is just an extra little section. This has to do with my Libraryville layout. This is my only HO scale layout currently. And although I designed this to also have selections, and the reason I have selections is there are areas here that I wish to place locomotives, and I do want the ability to turn the track power off. I have a massive turntable here, and that turntable has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 active spurs on it. The roundhouse, there's 3 covered roundhouse options right here, and I wanted these so that I can pull a train in there, and that train can be sitting in there and absolutely no power going to it whatsoever. Now, I been extremely ingenious. When I built the desk train layout, and even before it, um, I decided to build what I called a remote control scenario. So I came up with a situation where I could use one set of my controllers, those 4 transformers. I put them in a box, and then I put all the controls, all the turnout controls, all the light switches, and the 4 transformers, all the selectors, all in one box. That box is external to the layout. Then I used wires. I actually used printer cable wires, so I could detach them from the controller box at will and then plug them into the layout. The back of the layout has printer cable or serial cable connectors, just like the back of the controller box. Remote controller box, they're actually serial cables. They're 25-pin serial cables. There's 4 of them, which provides me with 100 leads to go from the controller box to the layout. And I designed it in such a way that those first 25 blocks, or 24 blocks, plus the common, run on the first serial cable. The next serial cable takes in all the turnouts and actually takes 2 more serial cables to get all of the turnouts. And the 26th block is in the second. So basically, I use that same configuration on three layouts now. I am making the remote control for this particular layout. But it was at the tail end of making the desk train layout that I discovered DCC. So for that, it was real simple. I just disconnected the controller, the first 25-pin serial cable, from that controller, made another little box, and actually I didn't even make the box, I just brought up the Digitrax command station and plugged 2 leads into the Digitrax for rail power. 1 lead goes to pin number 1, which is the common. The other 24 pins in that particular cable, I just grabbed another male-to-male 25-pin serial cable, and then halfway through the cable, I soldered pins 2 through 24 all together as one. Okay, so basically, I end up with just 2 leads, even though there's 25 pins in the serial cable. Only 2 ends are on one end. The other 25 connect to the back of the layout. Those 2 go into my DCC command station, and my DC command station runs everything. This layout was built with the capability to do the same thing, even though I'm currently making another turnout, and in the another remote controller box. The other remote controller box for this layout, which is backwards compatible with the other one, includes relay switches to control the dwarf signals and turnout signals that are physically placed on this particular layout, and they don't have to be on the old layout, but if I decide to go at them, they're there. So that when I hit my turnout button, if there is an available signal indicator there, it will also operate it. So that's what's currently in place. And the new remote controller box that I'm making for this layout includes my Digitrax DCC command station and a Digitrax Wi-Fi controller, so I can use my phone and just run the layout. Okay. Temporarily, I do have my turnouts just kind of sitting on the local control panel. So the idea behind this layout was and is that I can use the remote control box, which will physically be fitted and seated right here, which can be connected and disconnected at will and go connect to another layout if selected, or while it's there, it can be used. And like I said, I can use my phone if that thing is plugged in and just run the entire layout and everything's fine. Or if I choose to have guests over, there's an exact duplicate control panel here and one sitting right here. So someone could be standing here, sitting here, or there and operate the layout. You can operate all functions from either side. Right here is the turntable controller. Not turnout, but the turntable controller. And it's a Bachmann, standard DC controller that is attached to this layout, that if you move it forward, the thing rotates forward. If you move it backwards, it rotates backwards. But other than that, everything else is going to go through the turnout. So the selector switches, I'm not really using selectors on this particular layout. I'm using Digitrax DS64s to control blocking and control the switching, so everything is touched. You can either press a button and it'll turn on a block, or you can toggle a switch via the DCC command, and that will cause the block to turn on. So even the blocks, everything, when I'm done with this, I don't have to even be anywhere close to this layout and can run it. Okay. The idea was, it's called the Library View layout because it was supposed to be put in my library, which is I'm right now in my bedroom, but across the hall is my library. And early on while I was making this, I was speaking to a gentleman, a good client of mine for quite some time. He said, Henry, what might be cool is if you had a video camera set up on the layout. And if there's any way that somebody could remote in and run your trains, or if nothing else, if someone could be watching the video live while you run one of your trains so that they can see it going. So the idea is to be able to completely run this layout at some point in time without being physically present at all. And I got all the ingenuity built into it to be able to do exactly that. So it's just a matter of finishing it. And the layout itself is built. You may have seen that in many videos throughout the thing. Right now, the turnouts I am moving manually from this one station. They're not sitting over here yet. There's the controller that I'm building. It's underneath this layout right now. It's in a box by itself with plexiglass, 2 layers of controls. It's just taken me a while to, complete its construction, but its design is already in place. Everything's already designed to make all of what I'm telling you work. Okay, coming up on 7 seconds left. So that's pretty much it. I think I've accomplished the task here. Now it's just a matter